you know, I have all the different videos out there, and I didn't really have a good one for math. I'd done it a couple years ago, but the math questions are the same. It's just that we're seeing more frequently these 10 issues come up. And again, you want to be able to get all 10 of them. Now, the average person will say some of these aren't really math questions, and that's true. Like free fall distance, you really don't probably have to use a calculator, but it is a kind of a math question, and you have to be able to know this. So we're going to go through this. We can answer in the chat. If you have your calculator handy or on your phone or your portable one, that's fine. But we're going to cover what I have seen from talking to all the CSPs that have passed this year, what they're seeing in the math area come up quite a bit. And we'll get started here. Again, we don't use the actual board questions because the board has told me and ASSP you got to rewrite them. Even though they sell Exam Core, which is exactly the same questions, 1,000, you pay $1,000 for 1,000 questions and you get 5 or 6 on the test. So that's pretty pricey to get 5 questions. The first one, number one, almost everybody's getting the cylinder volume question. You may get lucky and not get it, but I would say probably 85% of the people taking it are getting this question. And you have to calculate the volume of the cylinder. It's the height times pi times r squared. Pi r squared is the area of a circle. Then you just multiply it times the height, and now we have a volume of the cylinder. The key thing to remember is sometimes the question, rarely, will give you a diameter instead of a radius. So radius is from the center of the circle to the outside. The diameter is the hole, that, you know, bisecting the widest part of the cylinder. So 2 plus radius plus radius equals diameter.
Multiply by 2.
So let's go do the first one. What is the volume of a chemical tank that's 16 foot high with a 5 foot radius? And they expect you to know this formula. They may give it to you on some questions. They may not give it to you on some questions. So we'll go until we get somebody put this in. All right, excellent job. Oops, it is B. So radius is 5, height is 16. The height times pi times radius squared, which is radius times radius, is 16 times 5, which is 400, times pi, which is 3.14. And the volume will be 1256. Usually the answers are not close. Only in a heat stress, which is a rare question to get nowadays for CSP, would it be close. So if you can do this, that's an easy 1 point. And remember, you need to get 107. People ask, is it out of 200? No, it's out of 175. There are 25 practice questions, I call it. They come out in May with the CSP. They come out with, last year was 170 some questions, I think it was. They're going to try these questions out as they see people are statistically getting, 60-70% on them. They'll probably keep the question. If it comes up that people are getting 35%, 40% on it, they're going to probably take it and revise the question because obviously it's confusing. Some of these questions are bad, and you will recognize them. What was your question?
Ron, are we recording this session?
I recorded to put it on YouTube later because not everybody can take off work to watch this. So you'll only see the screen. You won't see us in the video at all.
Yeah.
All right, free fall. Everybody's getting it. Now, the CSPs are getting an average of 2 free fall questions. We've had some people get 5 of them.
Yes, sir. I have given it. It was 5 questions by CSP test.
Yeah, so let's go over it. Let's talk about some issues here. What we have to do is the free fall is the act of falling, and then the fall arrest system, the lanyard, will start to decelerate the force of the fall. So it's really the free fall of our typical lanyard. 6-foot lanyard is the maximum that we see a lot of times out on the site. You can make them longer, but 6 is a common number. So if I take a 6-foot lanyard, tied at the 5-foot height of a D-ring, how far would I fall? Okay, you had 3 to 4. Okay, that's what I said. 2 is average. We've had up to 5 for some people. So what we have to do is, this is a hard concept, but the 6-foot lanyard is going to fall the 5 feet to the ground level. That's how high the D-ring is. It won't activate yet. It'll fall because you're tied below your feet. And then the D-ring is here. It's going to move another 6 foot the length of the lanyard. You will fall 11 feet. That is what catches a lot of people. Now, they're going to ask you free fall distance and free fall clearance, a little bit different on there. So again, what we're looking for is how far does the D-ring move with our fixed length lanyard. And it'll move 5 feet from to the D-ring. The D-ring's here now at the floor level, and now you're falling the length of the lanyard. It'll be 11 feet, 5 plus 6. Here we're going to tie at the same level. Our anchorage point is a connector strap. Our D-ring height is the same. We use a 6-foot lanyard. Our free fall distance is 6 feet. Now, they used to make you memorize some of these numbers, and then I was showing them on the safety factor. There are, ANSI had 2, some private manufacturers have 3, and so they will give you the number. They will never put these as blanks. You will always get the formula for this. You just have to put it in. So they will expect you to say, okay, the free fall distance, 6 foot, lanyard, you're going to fall right about here, and then the D-ring is going to activate a maximum of 42 inches. That is the standard for OSHA maximum free fall distance. It won't exactly do that in real life, but it'll be what the industry uses as a maximum deceleration distance. So now it's opened up 42 inches. Now you're going to have that person typically be 5 foot from the D-ring. It could be shorter or longer. And then the stretch of the harness, it's going to move up a little bit. It's not going to move 3 feet, but probably more like a foot of 16 inches. And so we'd add all these 3 numbers up, and it would be 17.5 foot clearance. They'll give you these numbers. You just have to know how to put them in. And, you know, and I just think it's pretty easy. But they'll usually tell you that using a 6-foot lanyard and a person has tied off at the anchorage, the elongation for your lanyard is 42 inches. The height of the worker back D-ring to the floor is 5 feet. Safety factor of 3. What is your fall clearance? And you just add up these numbers and you'd get it. You don't have to worrying about figuring out what the number. They'll tell you the safety factor. Okay.
So John, in this question, like we are not considering the height of the worker.
What do you mean by the height of the
Considering
worker?
it from
They're telling you the height from the D-ring to the floor is 5 feet. That's what we call. They're not looking at the total height from the head. They only care about the D-ring, which is in the center of your back. They're telling you that number is 5 feet. You just have to remember that, you know, there's a lot of variables in this. So, and then, you know, the height of the connector, what they're doing is telling you it's the same level. So you're going to fall this length of the lanyard, 6 foot. Then it's going to right about here, so that's 6 foot where the D-ring is now. Then it's going to start to stretch. I'm sorry, I click on the screen and it activates. It's going to open a maximum of 42 inches. That's your worst case. Not that it'll ever even be close. And then, of course, the worker's D-ring to his bottom of his feet is 5 feet. And then we add 3 feet after that. And so we get combination of all these numbers, we get 17.5. This gets frustrating because you don't realize that you got to know what this free fall distance is. If you get that wrong, you're not going to get the calculation right. And that's, you know, a common error. Sometimes the test will give you this type of a question. And I've seen this come up a lot. You know, 4 years ago you didn't get this because of all the issues with the free fall distance and the different numbers. They're giving you this one. So we have a free fall distance. The anchorage is positioned above the attachment point. So what we're doing is, if I'm going to just stop share, this is my 6-foot lanyard here. Now, I'm tied off at the back of my D-ring. If my anchorage is 2 feet above me, I'm only going to fall 6 foot minus the 2 feet. I'll only have a 4-foot free fall. Does that make sense to everybody? I'm dropping everything here.
This is how much height you are taking for your connector. Like in earlier case, we took 5 feet.
No, they're just asking free fall. Your anchorage is 2 feet above you, 6-foot lanyard. Your free fall distance is 6 minus the 2 feet. If I was tied off at this level here where my D-ring is, I would fall the length of this lanyard 6 feet. And the reason I bring it up, because a lot of people are missing these questions. Oops, keep on dropping everything here. And I'll back up here a little bit easier. Again, this is 6 foot. If I tie here in my D-ring and I fall this, I'm going to fall the length of the lanyard. It's going to go this whole 6 feet. If I tie 2 feet above me, I can't fall this distance right here from the anchorage to this. That 2 feet is not going to fall. It's already there. I'm only going to fall the slack of this 4 feet. Does that make sense? So it's relation. They'll tell you the height of the D-ring won't matter. It's just telling you what it is relationship to where it's at. And the reason I bring it up is a lot of people keep on thinking it's 6 foot free fall. No, if the anchorage is 2 feet above you with a 6 foot fixed lanyard, then you're only going to fall 4 feet. You're not going to fall 6. If I have it up 6 feet above me where it's right on my D-ring, I'm not going to fall any feet. So that's why I show that example, because a lot of people are missing these questions because they automatically say it's a 6 foot lanyard, it has to fall 6 feet. No, depends where it's anchored at. All right, let's go into share screen. Determine the free fall distance when the anchor point is positioned above the head. What is the formula? Free fall distance equals lanyard. That's never true. Remember, it's 2 feet above me. I'm only going to fall 4 feet. I'm not going to fall the 6 foot lanyard. Free fall distance equals lanyard length multiplied. There's nothing about multiplying anything in these calculations. It's all addition, subtraction. Free fall length equals lanyard length minus the distance between the attachment and the anchor point. That's true. Remember, the lanyard length is 6 foot minus the distance between the attachment, which is 2. I'm going to fall 4 feet. You don't add that because you're not going to fall 6 plus 2. You're not going to fall 8 feet by having it above your head 2 feet. This is a common question that is driving people crazy. They're missing this. They're missing the version of, this. And it's not uncommon for some of the people, when I've gone through it, to miss 4 out of 5 or 5 out of 5, because this free fall and then free fall clearance are two different things. We have to know where the lanyard is anchored to. We're always going to assume the D-ring's in the middle of the back, and that's free fall. All we need to know is those two numbers. We don't need to know the height of the worker. We don't need to know how far they're above the ground. We just have to know where the anchorage is, the length of the lanyard, and the anchorage relationship to the D-ring. All right, that's the hardest thing of all these questions here. Okay, so the answer is C. All right, that's tough. And like I said, it used to be the CHT got these questions, and the CSP last year. Now the CSP is getting a lot of these questions, and they're getting stuck with it because it's something they're not used to using. Because when you normally go out there, you just says the worker's tied off, and he's not going to hit the ground because he's 20 feet above it. You don't even do this calculation. But if you're up like 10 feet up, you might have to do this because they could hit the ground before this thing activates, especially if they tie to their feet, which I see a lot. Incident rate calculation, pretty simple. The amount of cases on your OSHA 300 log, or your log of injuries for the year, times 200,000 divided by the hours. Now in 1971, they made it 200,000 hours because if they just took the injuries divided by the hours, it would be 0.00, and people just didn't like these small numbers. You didn't know when you got 0.001, was that a good number? When it's above a 1, people can understand. 10 is bigger than 3 and hundreds bigger than 10. So the incident rate was multiplied by 200,000, which represents 100 people working 2,000 hours a year. And it's going to be a bigger number than, and remember, it's a rate. So if I have 1,000 person company, it's just the hours, the injuries for the log for that 1,000 person company times 200,000 divided by the hours. It's not going to depend on the Pete. It's a rate per 100 employees. So that's a simple one. That if you get that kind of question, it's an easy question. Once in a great while, you'll get something like this. And this is from one of the exams, and they'll tell you we got lost case time, medical treatment, first aid, property damage, auto claims. We worked 450 employees, 2,050 hours a year instead of 2,000. What's the incident rate? This is exceptionally hard. First of all, we got to figure out what's on the OSHA 300 logs. Lost time cases, medical treatment. First aid is not on there. Property damage, not on there. Auto claims, not on there. So I call this a case of too much information. You're out there thinking I got to use all these 5 different categories. No. When you want to just calculate an incident rate, you're just going to use these 2. How do I determine the hours? 450 times 2050 gives me my hours for the year. All right, so the number of cases times 200,000 divided by hours. Let's see if anybody can do the math on here. I'm going to get my calculator out here on my phone here and see what I get. Wait till a couple of people put their answers in. Your answers are A, 6.5, B, 7.5, C, 8.5, and D, 9.5. All right, very good. It is A. It is A. So we have 14 cases in medical treatment. These are the 2 entries on the 300. 14 plus 16 is 30 cases times our 200,000 divided by our hours. 450 divided times 250 is 922,000 hours. The incident rate of 6 million, which is 30 times 200,000 divided by this, equals 6.5. That's as hard as it gets, but the simple ones, you can get a simple one where it just gives you the amount of hours and the number of injuries, and you have to look at it. Just have to remember that the OSHA 300 will have lost time and medical treatment, but not first aid. Okay. Then the radiation one, the ASPs get the inverse square law a lot. The CSPs get the half-life question, it seems like. So I would say probably 60% are getting the half-life question. Radioactive substance has a half-life of 20 years. So if you start out with 100 grams, at the end of 20 years, you got 50 grams. That's what they're going to do for one half-life. Now they're asking how much would remain after 60 years? 100 grams, 50 grams, C, 12.5, D, 6.5. And there's different ways to do this, but I'll show you the way I do it. Okay, it is C. Very good. So I just do it like this. I draw it out, and we just do half-lives. After 20 years, you got 50 grams. Another half-life would be to 40 years. We have 25 grams. After 60 years, we got 12.5. That's an easy way to do it. If you just do it this wet method, you can actually go. They're not going to give you something, for a million years. You wouldn't have to do this for a million years, but you can sit there. It's usually 2 or 3 half-lives they would go through, and they'd ask you about it. But that's, what you would go through. If we did one more year, it would be 80 years. It'd be half of 12.5, and we'd get 6.25 grams. So pretty simple question, but a lot of people freeze because they're thinking they're not giving me the formula. You don't need the formula for half-life. You just have to remember it's going to lose half the radioactive part every so many half-lives. So one half-life is 20 years. You're going to lose half of it in 20 years. If you just remember that, that's okay. But this is, again, you're out there and you're taking a test with 73 different topics on the CSP. You've understood how to do like the inverse square, but you kind of know half-life, what it is, and then they give you a question that does require you to do this iteration. Okay, excellent. Return on investment. This is a calculator question for some. Some they can just draw it out. Remember, you're going to get a dry erase board about the size of a piece of paper, and it'll give a black marker, and you can make your notes on it. So return on investment is a little bit different from cost benefit, and it's just a subtle one. They usually will give you the formula, but not always. Some people said, I didn't get the formula. That's like a small percentage, like 10-15%. Company's going to spend $50,000 on guarding a system. They're going to put like a laser curtain or a light curtain or something else to prevent hand injuries. And the next year they avoided 5 injuries, which would have cost $15,000 in treatment, which is exceptionally low. And that's $3,000 in injuries. But what's the return on investment? The formula is the gain from investments minus the cost of investments divided by the cost of investment. That's all you have to remember. If they give you the formula, all you have to do is put the two numbers in and go in there. So is your answer 20%, 50%, 100%, or 150%? This is a tough question because a lot of times when you're dealing with these percentages. So let's see if we can do the numbers, see what you get. Because a lot of times people are not confident about this because they don't do this a lot. Times 5 was not 75,000. So each injury we avoided is 15,000 times 5 injuries is our savings. We spent 50,000 divided by our cost investment, which is 50,000. We save 75 minus 50 is 25,000. 25,000 divided. What messed me up, and this is, you can see I just messed up. It says 5 injuries each, which cost 15,000. I was thinking this was a total cost, and I just overread it. So you can do the same mistake I did. You have to figure out what the savings is, and that's good. Good catch, Mark. But that's what you want to be able to do. You're going to save 15,000 times 5 injuries, 75,000, by implementing a $50,000 system. So we're saving 25,000 a year. Okay. Just a tough question to get into, and don't be surprised if you're in a situation where, you look at it. Some of these math questions you might flag to the end and just, when you got like 40 minutes, you got 20 minutes on 2 math questions to sit there and look at it. But you got to figure out what the gain is from investment. I did the math wrong. I'm thinking it was, for whatever reason, 15 times 5 was not the right number. Okay. Pythagorean Theorem has come up this year. I'm really surprised. I don't remember it being in years. It's been 10 years. Like, I've been doing this since 2005. You got to go back like 15 years ago where we had that kind of come up. But everybody seems to be getting it now. Over half the questions are getting a simple Pythagorean theorem. The ladder is leaning against the wall 12 feet high. So the wall is vertical, is 12 foot. The base is 5 foot away. So Pythagorean theorem is a squared plus b squared equals c squared, the c being the hypotenuse or the diagonal. So how far does the ladder have to be long to reach that area? Now we're not going on top of the roof, we're just working on a wall-mounted unit. So this is a simple one. 5 squared plus 12 squared, add them up, take the square root of them. Some people, this is where you would need a calculator. You usually can't do square roots in your head unless it's, single digits or double digits and stuff. Very good. It is A. So a squared plus b squared. I have to cut and paste this because when I put it in the file section, they won't recognize these superscripts. That's what this is. C2 is a superscript. So 5 squared plus 12 squared equals 169. The square root of 169 is 13. That's convenient. It's nice and even. Not always is it going to be nice and even, but somebody remembered I got a 12 and a 5, and that's in there. So this is geometry, or algebra, whatever you want to call it, because it's dealing with something over 2,000 years ago that they came up with this theory. And you notice one of the things that you're seeing on here is these are all getting scenario based. As let's say put 170 questions out, I would bet you that probably 120 are scenario based like this. And instead of just saying the vertical is 12 and the horizontal is 5, what's the hypotenuse? They're giving you things that are related to safety. They're trying to justify the safety math, as I call it. So that's a big change, and that's coming up quite a bit. So just be aware that when you get these word questions or these math questions, there's a lot of times they're going to tie to a scenario now. How would you do this? The calculator square root. Well, let's see where I put the calculator at. Oh, let's turn it on. So if I look at the calculator, you put 169, and then there's a square root function in the green. It's very tough to see, right above this x squared button. So I hit the green button called second, and I hit second, and then I hit the square root, and then I enter it. Okay, so come here. Second square root 169. So you'll see I've got second square root, then I enter 169, and then I go to the enter button here, and it should say 13, and there it is over there. So this is, with the TIs, kind of a different type of thinking. Normally you would just hit 169 square root. Here you hit square root 169. So that's why I tell people buy this and just play with it, because when you get it on the screen and now you can't get it to work, it's going to get frustrating, and that's when people get mad, because they're like, I'm using a calculator. If I had my own phone, I could do this, but I can't do it on this TI calculator. It's because TI has a different one. HP is even worse, different logic, the syntax of how you put the data in. Okay. All right. Then statistics. You're always going to get a statistics question, 1, 2, 3, or 5. And they may ask other things. There's a whole statistic YouTube video, but what everybody's getting is a mean, mode, or median. One of those questions. That's what almost 100% of the people are getting. And they want to know what is the mean number of observations. So again, a scenario-based question. We're doing the calculation of 4, 6, 5, 5, and 10. So there's median, which is in the middle. Mode is the most common. Mean is our average. So that's sometimes with these 3 M's, it confuses people because they blur which one is which. But what you're doing is you're trying to figure the average out. So we just add them up, divided by the quantity, which is 5. And everybody's got B as the answer, and it is B. So add these numbers up. 4, 6, 5, 5 divided by 5 is 30, divided by 5 is 6. Should be easy one to do. Yeah, the calculator mark is available when I did it like 8 years ago, and I can't get it at all. You can't even buy it. It's like, so it is a free option for 90 days if you take it beforehand. After 90 days, you're like me. You got to buy the calculator, because I don't know why they can't sell it to you for like $15 online, but they give you the free trial, then you can't buy it. It drives me crazy. All right, now we got to do the median. Well, that's the middle. It's always going to be odd number of data. So the number of near miss reports, we had 3 near misses, 8, 6, everything else. So the first thing we got to do is put this in order from 2 to 8. And what is the middle number? So what do we got, you think? And it is right. We sort them up, the one exactly in the middle. Most time you're getting 7 numbers. We've had people get up to 13 numbers. So you just have to write it down and pick it. And it's important because generally, you know, it should be somewhat close to the mean, but it isn't. These numbers are all over the board. And then, of course, the mode. You know, I use this all the time when we get testing in these OSHA classes where we have the OSHA 500 series where we give them 35 questions. We ask them, what is the mode? What was the most common answer out of 35 questions right did the class get? Because we want to, you know, the median's nice, but I just want to know, where's the chunk of people getting it? And you know, you could use both of them. But here we got 2, 3, 3, 4, 2, 3. What's our mode in this case? And the answer is, indeed, B is the mode. 3 appears 3 times, so that's the most common one. And it's just, for me, I can look at it. That means a chunk of students. Like if I get after doing thousands of these tests at 35 questions, the most common mode out of 35 is 33. The median will probably also be 33. But you know, there'll be people that get 28 and lower. There'll be people that get perfect. But I just want to know where is it going, because, you know, I like to get a 33 out of, you know, if passing's 28. I don't want to have people just barely pass. I don't want to have my median be 29, because then I might have people pass. I want to make sure they try to pass, so repetition is going to be an important issue. This one is coming up a lot lately. You know, it was big and then it disappeared and now it's coming back. And you got to be able to convert from ppm to percentage and vice versa. So I got a simple one. We got 5,000 ppm of carbon dioxide. That's what they call, you know, carbonation in soda pop, and it's from decaying plants, and generally harmless at low levels. But OSHA's permissible exposure limit for carbon dioxide is 5,000 parts per million. What is this as a concentration as a percentage of volume? So this is, you know, something you have to be able to convert. And I'll show you what I do. It's a little longer, but this is, I just want to say, I can't remember these numbers, especially when I get to, you know, 500 parts per million, 50 parts per million. So most people have picked B already, and that's correct. Again, 0.5. So I start out 1 million parts per million is 100% of it in air. At 10%, you would just take 10% of it, it'd be 100,000 parts per million. 1%, 10,000. There's not a single substance in OSHA's thing that says you can breathe 1% of something that's regulated. You know, you have oxygen at 20.9, nitrogen 78%. That's what normal air is at. But there's nothing for any solvent or anything else you could breathe it. Carbon monoxide would be there, but I would write down 0.1 is 1,000. So when I have 5,000, then I know it's 0.5. That's how I do it. It sounds crazy to write this thing out, but I do it and I never make a mistake, because then it's easy to figure out the 5,000 between the 1,000, and therefore if this is 0.1, this is 0.5. You get gases like this, acetone. That's a solvent used in paint and used for fingernail polishes. 100 is styrene. Look at how small percentage in this. Your meters of oxygen for your combustible gas meters won't even show 0.1. You know, they go out to, you know, 0.1. So when you got this, you could be overexposed to styrene. Hydrogen sulfide, you'll have a meter cell for that probably on a 4-gas meter, but look at 0.01, that's small. Then your cancer-causing agents like benzene and Hydrogen cyanide, 0.00%. So small amounts could be very lethal, and that's what you'd have to be able to convert to. You may get something, we detect 3% of this in air, and I'll pick xylene. Xylene is a PEL of 200. We detect 3% xylene on our meter because we have a meter that'll read xylene. Well, if the PEL is 200 right over here and we're at 3%, we're at 30,000 parts per million. That's a lot of, that's a lot of gas. We're going to be dead with that solvent. So that's what I run into. Generally, when they ask you, they can make this and make it as complicated as they wanted to. They can go in there and say, we detected this gas at this percentage. What is it? Here's the PEL. Are you over or under? They could do that kind of, scenario. But by writing this out, it gives you the numbers when you get percentages or vice versa. You just have to be able to go back and forth with them fairly easy. And again, a lot of people, when they take it, they kind of know the concept. They don't do any of the math questions. They don't practice it. Then they get this question, and now they're like, I can't remember the conversion. I can't remember how many parts to percentage. But if you do it this way, like I do for the last several years, you don't mess it up. Okay. Cost-benefit analysis. Okay, this is our last one. This is a little bit tougher. You're going to put fall protection system in. You're going to prevent incidents of 60,000. What's the net benefit after 1 year? So wait a minute. We're going to spend 25,000 to save 60. That's all you have to think about. What are we going to save in this case? Don't make it any harder than it is. It's like part of the ROI calculation, but it's just the first part. I use this all the time with ergonomics. And it's going to be, the benefit is the cost minus this. So what I run into in ergonomics all the time is, how many ergo injuries do we have for this process? So they're going to go out and they're going to simply lift a 50-pound bag of food product and put it on a pallet. So they're going to lift it at waist level, bend down, and put it on a pallet. And I asked them in a year, how many do we have? We had 3 injuries. Total cost is $120,000. I'm going to go out there and I says, okay, for $15,000, we'll buy a device that lifts it up with vacuum, puts it on the pallet for you, and you just guide it. Well, we're spending $120,000 a year. We're only going to spend 15. It's 120 minus 15. They said, no way we're saving, that kind of money. And I says, you're saving 105,000 right there, right there. 105,000 is a lot of money to save from what you've seen over years. I was at Ford. We went through the parking lot. In average cost of parking lot potholes cost them about 200,000. Remember, there's like 4,000 people working at the plant, and you come out and they trip in a pothole and they, rip the knee out, they sprain the ankle, rip a tendon on the hand, and everything else. The record I have in my state at one company was 17 slips on ice in their parking lot. Over $1 million of loss. Well, we can fix the potholes fairly cheap. Ford's going to spend $20,000 to fix it to save, thousands upon hundreds of thousands. This is stuff you do right away in safety because it makes a difference right away. They see the savings right away. And then once you save them this much money, then you can start working on the other stuff. All right, so these are the common, questions you get. Is there any other questions on anything else that you've probably seen or had another issue on? Okay. Appreciate you coming in. Thanks for catching the one issue. Like I said, you can do this over and over, but you can still make a mistake. So appreciate you. If you go to the BSC study group, there's a file section. When you click on the first time you're in it, there's a file section way over on the right. I'm starting to put all these questions down, what they call the examinations. There'll be at least 30 questions, fire, risk management, and eventually we'll have, the 60 different things in there over the next, 5, 6, 7 months and stuff. It takes me time to write down all these explanations, but that's the next step, and it'll be available for you right now. You can go there. You can get at least 10 of them, plus other study guides that other people put in, and I'll see you guys next month. Take it easy. Thanks.
Thank you, John.
Thank you.